Hello everyone, my name is Mizanullah Chaudhary. I am from MIT Aeroastro department. Today I would like to talk about International Space Station based online virtual lab for STEM education during the COVID-19 pandemic. Before I start, I would like to give thanks to the ISS R&D committee to giving me the opportunity to give this presentation today. COVID-19 has dramatically transformed the way we approach education. It stirred the educators to think creative way to prevent the disruption of learning caused by school shutting down. During the peak of the global lockdown, nearly 1.6 million children were out of the classroom. Preliminary research has shown that being away from the classroom environment has led to greater mental health problems and significant learning loss in STEM subjects. Despite the statistics, blended learning modules combining home-based or e-learning and in-classroom teaching are likely to remain the status quo for years to come. Home-based or e-learning ecosystem were adapted using flexible learning methods to enhance students' individual learning abilities. It assigns teachers a significant responsibility to expand students on virtual tutoring skills and experience. Despite extensive efforts to bridge the gap between different teaching strategies, in the development of flexible learning, online learning skills lagged behind. Prior to the pandemic, young people were already being left behind for lacking the skills needed to enter an increasingly technology-driven workforce, particularly in low-resource communities. Global lockdown measures exacerbated this troubling trend, and the negative effects will continue without innovative education intervention. International Space Station-based STEM education has played an important role in providing students with hands-on educational opportunities that transcend passive learning. However, students in low-resource communities and developing nations do not have access to ISS-based projects due to social, economic, and other significant educational barriers. Students from developing nations like Bangladesh benefit tremendously when they earn degree in STEM field. Highly populated countries like Bangladesh represent an emerging opportunity. Educating the citizen of Bangladesh has the potential to bring fast economic growth and effectively alleviate social and economic disparities. In response to the growing need for innovative technology-based education platform, we developed STEMX 365 to make the STEM education more accessible to all students using learning modules inspired by space science technology. Through our case-based 3D virtual learning environment, students will develop skills that they can apply to excel in school and eventually the increasingly technological job market. We are building interactive, immersive, and accessible tools so that students can be in charge of their own learning. STEMX 365 has developed online interactive virtual labs including MIT Spheres, NASA Astrobi, CubeSat, Arduino, ArcLab, and Space Biology. Currently, STEMX 365 is working on Astrobi, Spheres, and Art Virtual Lab. In the future, we hope to add more space-related labs. The goal here is to be able to break down otherwise complex scientific principles into bite-sized information that any student can digest and learn. The mission of STEMX 365 is to train students in developing nations to cultivate the technological literacy necessary to meet the demand of the increasingly digital global economy and become the leaders of tomorrow. STEMX 365 platform has been developed utilizing the Docker architecture. The Docker architecture follows the client-server model. The Docker client communicates with the Docker daemon which does the heavy lifting of building, running, and distributing Docker containers. Docker architecture has several components like Docker client, Docker host, and Docker registry. Docker client is used to trigger Docker commands. Docker host is a physical computer system or virtual machine running Linux. Docker registry, or also termed as Docker Hub, is a registry for storing Docker images. In this diagram, under host, I am showing S2B simulation, S2B IDE, which is Integrated Development Environment, S2B game development, and identity. These are all Docker containers. We build a Docker image of S2B simulation, S2B IDE, S2B game development, identity, and store those on the Docker Hub, and we create containers from those images based on demand. So when a student work on a lab, we dynamically create all those containers for a student, and when they're done, we delete those containers. But we store their code on the GitHub. STEMX 365 platform is built on microservices architecture. Microservices architecture is a cluster of independent microservices, which is the breakdown of monolithic architecture into several smaller independent units. These microservices are meant to handle a set of their functions using separate business logic and database units that are dedicated to them. This is an example of S2B lab microservice architecture for a single user, which includes simulation service, integrated development environment, game development, and visualization. Identity of each student is managed through internal and external identity provider. All microservices share the same database. STEMX 365 platform uses automated cloud infrastructure to reduce the time required to deploy microservices. This is an example of game development automated process. Developers check in their code, which is verified through the automated test and build process to ensure success in integration between builds. Jenkins is a build tool which builds the Docker images from the newly checked in code and uploads the Docker image to the Docker Hub. After successful build and upload, Jenkins downloads the Docker image and run the Docker container in the cloud platform like Google, AWS, or any other commercial platform. STEMX 365 platform was designed to provide a common place for organizations and education institutions to run space robotics tournament. Each organization will be able to set up tournaments for their students using STEMX 365 laboratories. Currently, our lab of focus is for S2B, which utilizes NASA's open source S2B repository. We hope to build S2B hardware which can be remotely connected from the online virtual S2B lab. This way, a student will be able to operate S2B robots remotely and learn the basics of space robotics and programming. We developed an online-based common playground where students will be able to write code in C++ and Java, then run simulation, and then see the visualizations. We also provide graphical environment for entry-level programmers to build their basic knowledge about robotics programming. Students will write code using a drag and drop environment. Programmers will use coding instruction blocks to construct animated stories and games. Now we'll see an online simulation visualization which is running on STEMX 365 platform. These are statistics from the STEMX 365 Phase 1 in Bangladesh in 2020. We had 168 students from 48 teams. They came from 27 different institutions in Bangladesh. On average, students were around 21 years old. Our youngest students were 17 years old. Most students were male, and we aim to recruit more female in the future. Preliminary feedback about STEMX 365 thus far has been largely positive, and students want more contents. We asked question, do you have suggestion for improvements? They answered, we should hold meeting more often. It is great so far and really inspiring. I hope we can allocate more time for problem solving regarding simulation or coding. In addition to building these online platforms, STEMX 365 is leading the Kibo Robotics Programming Challenge, an Asian Herb in Space program in Bangladesh at no cost. Last year in 2020, during COVID pandemic, STEMX 365 introduced Bangladesh in the online Kibo Robotics Programming Challenge. Bangladesh joined as an observer nation. With that, students were able to practice coding space robotics. The objective of the challenge is to train the next generation of students in advanced programming so that they can become leaders of the fifth industrial revolution. This year, Bangladesh joined in the second Kibo Robotics Programming Challenge. STEMX 365 collected applications from 22 teams for this challenge. And then STEMX 365 worked with students to help prepare them to compete against students from other countries. We have seen a successful results. Bangladesh team Enigma system from BRAC University has won third place in the International Keyboard Robotics Programming Challenge. Now their code will go to the International Space Station, which is very exciting for Bangladesh. This is the first time Bangladesh students are sending code to the International Space Station. From STEMX 365 online program, in addition to advanced programming, students learn teamwork, collaboration, work ethics, leadership, demo preparation, and so on. Now I'll show a student demo of Kibo observation phase, which was done by Enigma system.
Hello everyone, we are Team Enigma from BRAC University, Bangladesh. So Astrobi starts from here. So there is a keep out zone over here box. So to go from here to P11,
Now I'll talk about Asian Urban Space for Bangladesh. This is another program under JAXA's Kibo ABC. STEMX 365 introduced Bangladesh officially to join in this program. The objective of this program is to provide students and young researchers an opportunity to learn about space biology. This program has two missions, Mission 1 and Mission 2. From Bangladesh, we send coriander seeds as per JAXA's plan in Mission 2 to research space travel. In Mission 1, Bangladesh will be involved in growing basil seeds in ISS and ground. Now I'll show a video of ICE program.
Thank you very much for watching Asian Arabs in Space over the last 30 days. Students from Bangladesh, Indonesia, Japan, Malaysia, Nepal, Singapore, Taiwan, Thailand, UAE, Vietnam.
Now I'll talk about STEMX 365 timeline. In April 2019, we created STEMX 365 and developed the basic web platform. In June 2020, STEMX 365 introduced Bangladesh in Kibo ABC program, started recruiting students, and then Bangladesh joined Kibo Robotics Programming Challenge as an observer country. In July 2020, all students learned how to install Android Studio, write code, and build Android package kit, which we call APK. In August 2020, 13 teams were able to upload APK to the JAXA's online simulator. In September 2020, students were able to continue to practice and learn about programming. In December 2020, Docker-based Astrobe simulation was developed. In January 2021, Bangladesh sent coriander to ISS through STEMX 365. In February 2021, a common online virtual integrated development environment was developed. In March 2021, a Java-based online Astrobe IDE was developed. In May 2021, students from Bangladesh joined in second KRPC. Students used STEMX 365 platform to practice coding. Finally, they uploaded code to the JAXA's leaderboard for competition. Overall, STEMX 365 is dedicated to help train students during the current pandemic and beyond to cultivate the technological literacy necessary to meet the demands of the increasingly digital global economy and become the leaders of tomorrow. Ultimately, the goal is to encourage young people to cultivate hands-on skills by providing them with the opportunity to explore science the way that some of the world's smartest people, such as astronauts and rocket scientists, do. The International Space Station based online virtual lab serves as the perfect avenue to meet the goal. So what is next? As we work with our students, we are learning about the things that work and do not work for them. So our plan is to continue to create more tutorials, videos, recruit educators, recruit more students. We'll continue to hold more seminars at universities, governmental organizations, and professional associations to discuss the benefits of online ISS-based STEM education. We'll continue to work with policymakers and university leaders to help integrate and encourage governmental funding towards online STEM education in public schools. We'll try to improve the online virtual development and simulation environment and make it more user-friendly. We are working for ways to fund the endeavors of STEMX 365 so we can continue supporting and inspiring next generation. Finally, STEMX 365's objective is not to teach students. We want to inspire students because when we are inspired, we are motivated to apply the things that we learn in our daily life. If you are interested in contributing and learning more, please contact with us on Facebook at www.facebook.com/STEMX365. I also encourage you to visit our website at STEMX365.org. Thank you.